Welcome, Hampshire chemistry students. Glad to have you today. I'm sad I can't be with you guys today, but don't worry, I'm around. I'm always watching. Okay. But you and I are together are going to look over our titrations homework. So make sure we pull this guy out. We're going to look over number 1 with us. Someone really helpful already wrote out a reaction. These should hopefully be second nature by now. Make sure you do feel comfortable doing things like naming your acids and your bases. Okay. But let's break down this question. We'll come back to part B here in a second when we need it. But let's go through and see here. In a lab, you are tasked with determining the concentration of HCl. Oh, that sounds like, day 2 of our lab. Okay, but you are deciding to fill your burette with a molarity of 0.255 molar NaOH. That sounds important. I'm going to go ahead and underline it. Okay, and we filled that burette up to the mark of, let's use some fun blue here, 15.5 milliliters. Okay. And then we measured out that HCl, so we needed some acid. Okay, we measured out 14 milliliters of acid. Okay, we went through and did our titration and all that fun stuff. Okay, and you'll notice that when we come down to this part, it tells you a bit more about the problem. It says that in order to titrate the HCl, we needed to lower our burette marker until it was at 31.8 milliliters. Okay, so it's asking us how much NaOH were we asked to find here. Okay, so we have to think about, hey, this was our molarity. This is where our burette started at, and this is where it ended at. And so you might be tempted to include this number here, but that is not of the NaOH. That is of the HCl. So to find our total amount of NaOH that we used, we're going to take that 31.8 milliliter endpoint and subtract it from the initial 15.05 milliliters. Okay, gonna make sure to tippity tap that guy into your calculator, and you will end up with 31. Oops, sorry about that. Of 16.75 milliliters. Okay, this is how much NaOH was used in the titration. So, more importantly though, we don't care about the millimeters of NaOH, I care about the moles of NaOH that I used. And that's what I'm going to need to do to convert to HCl. Okay, so I'm going to use my molarity equation. Okay, I'm going to multiply both sides by L and find that moles is equal to your liters times your molarity. So we can go ahead and set up this equation. Now, I do want to be careful. I'm not going to plug this number in, right? That's in milliliters. So we might want to go back and convert this guy from milliliters to liters. Remember that there are 1,000 milliliters in every liter, just like there are 1,000 years in a millennia, or 1,000 legs on a creepy millipede. But so, we're going to take this 16.75 and divide by 1,000, which will end up giving us 0.01675 liters. Okay, that is my amount that I'm going to bring down here and do 0.01675 liters. Okay, and hey, we know our molarity already from up here. We were focusing on the molarity of our NaOH. That's 0.255 molar. Okay. These two will cancel, and they'll tell me exactly how many moles I have. I hope when I'm typing in my calculator, if you're struggling, you are also typing in your calculator to work with me, and I end up with an amount of moles of 0.00. I'm going to go ahead and round to 3 sig figs, since all of our numbers so far have had 3 at least. Moles of NaOH. Okay. So that 427 is going to be super important as we move down into part F and part G. In part F, we need to use our answers from part B and part E to determine the moles of HCl. So now we're not worried about NaOH anymore. We're worried about HCl. So this is where we need to go back up to our equation and think about our ratio. Since this guy is already balanced, we can remember that there's always these invisible ones in front of their formulas. So the ratio of these two is very simply 1 to 1. So if I was going to do a very simple molar conversion, I would take that 0.00427 moles of NaOH, and then convert from moles of NaOH to moles of HCl. I'd make sure that the moles of HCl goes on the bottom, moles of NaOH goes on the bottom since I want it to cancel, and the moles of HCl go on top. So then all I got to do is then use my ratio of 1 to 1. So on the bottom goes a 1 from the coefficient, and same thing on the top. Easy peasy. Okay. I don't even have to pull out my calculator for this one because it's 1 divided by 1. It's going to be that exact same number for my moles of HCl. Okay. 1-to-1 ratios always create these equivalencies. So all that's left over here is to simply convert my moles of HCl into my concentration of HCl. Okay? So I'm going to again use my molarity equation, except this time I'm just going to take the moles I found divided by the liters. At this point I trust that you guys can set this up. I can tell you by far the biggest point that people mess up is this mole to mole conversion. Okay? Or if they mess up here, that messes everything else up. Okay? Now, I might be asking, what happens if I don't have a 1-to-1 conversion? Well, if you wrote your balanced equation correctly, like let's say we're in a fantasy world where you need 2 moles of NaOH. I know the world would be so much different where you had a 2-to-1 ratio here. So all that would change in my problem, okay, this step stays the same, this step stays the same. The only thing that that changes is when I'm converting down here. So I would still have the 1 for the HCl, but now I would have a 2 for my NaOH. Now again, this is not how we found our answer, but if you have different ratios, just use your equation to do the mole-to-mole conversion, and you will see those different types of ratios going forward. So if you have any questions while you're working, please make sure to email me. Please make sure to get help from the people around you, and you guys will be awesome because you know you are. Have a great day.